those experiments have refuted physical realism. Do you agree with this?
Yeah, no, I think there is a real problem in the interpretation of quantum mechanics. The approach taken by theoretical physicists for the past century, starting with Einstein, is just wrong. Space-time itself is behaving differently than we are usually describing it. So we are stuck. There are also interstellar objects over the past decade, and 2 out of the 3 looked anomalous. That should excite us. We should say, if we monitor objects that enter our backyard from the cosmic street, we might find a tennis ball thrown by a neighbor or something unusual.
What if God is an alien?
I have back the 2 most famous guests of our podcast so far. I don't know what we're going to talk about, but I'm sure this will be the best podcast that we ever made. So, Bernardo Kastrup and Avi Loeb, I give you the mic. Say whatever you want.
Well, that's a very difficult challenge because there is so much to say that perhaps we should say nothing until you ask us.
Where do you think there is an intersection between your work, guys?
Oh, I think the frontiers of science resemble in a way the frontiers of the humanities, the frontiers of the arts, because we are exploring the unknown, and it requires creativity, it requires courage, and only when you deal with what is already known, you can relax and pretend that you are an expert. So when you go to study the unknown, you behave like a kid because you don't know what to expect. And that's what a kid is like. A kid, is so young that they don't know what to expect. And so they are filled with curiosity and joy of actually exploring. And I think anyone that is creative, be it in the sciences, in the arts, or the humanities, would behave like that. When you see people pretending that they're experts, pretending to be the adults in the room, they are not creators. They are basically, they are attached to their ego. They're trying to show off.
Hear, hear. I think there may be an intersection, a more sort of explicit intersection between what you're trying to do, Avi, on the non-human intelligence question, which you have been exploring a lot. To me, that phenomena may have metaphysical implications. And when I mean metaphysical, I mean it technically. I don't mean spiritual or religious. I mean the thing that behaves, physics being the study of behavior. That which behaves, that which is behind the physics, the metaphysics. I think some aspects of the phenomenon seem to defy not only physics, but even our logic, our Aristotelian logic and the 5 Aristotelian axioms. I wonder what you think of it.
Well, I think that it's really unfortunate we live at times where scientists lost their curiosity, because if you go back 100 years, that was roughly when quantum mechanics was discovered. And nobody expected it. Nobody ordered it. It was not on the menu. In fact, about 20 years earlier, there was a statement made by Michelson, a famous physicist who gave a speech at the celebration, the inauguration of a laboratory in Chicago. And he said that pretty much from now on, physics will be about refining the measurements of constants, physical constants, to the 5th decimal point. And we pretty much know everything that is to be known. And then a couple of decades later, we realized through quantum mechanics, through experiments, that not only there is a facet of reality we did not recognize, but in fact, we can't really understand it. And Einstein was troubled by that. And he tried to argue that quantum mechanics doesn't have spooky action at a distance. And guess what? About 80 years later, the Nobel Prize was awarded for exactly the experimental verification that he was wrong. Okay, that in fact there is spooky action at a distance. It's called quantum entanglement. So this is just one example where, we didn't realize, and actually the mainstream of the science community did not realize something really fundamental about reality, and experiments revealed it. And I'm worried that right now nobody is really curious enough to look for anomalies that might violate what we believe in. And without this curiosity, without what I was talking about before, we would just put blinders and never discover anything different from what we already know. And that is really unfortunate. Now, maybe to our rescue comes artificial intelligence. That's a sort of alien intelligence that Alan Turing pioneered about 90 years ago. He thought about the imitation game where AI systems will imitate us. The religious version is that humans were created in the image of God. And the secular version of Alan Turing is that AI systems are created in the image of humans. And what I'm hoping from AI system is not so much for them to imitate all our faults, because already people are complaining they have biases. Some AI algorithms are racist. There was just a discussion about that. Some students created an AI, a chat GPT version of Claudine Gay, the president of Harvard. And in the Crimson yesterday, there was an article that said that there are racial biases to the system that they constructed, that somehow it's racist. So obviously, if you try to imitate humans, you will get their faults. It's just like looking at the mirror. And I want something better than that. I want something better than humans. And it's possible that AI would come to save us as an alien type of intelligence that we created. It's sort of like giving birth to children and then realizing the children are not like us, they are different. And these are our technological kids. And in principle, they can give us back that sense of curiosity, that sense of discovering new things, because they don't have the faults of humans that are pretending to know more than they actually know, that, that they are ego motivated, that are trying to show off. All these problems that I described before about scientists. So this is what I'm worried about, that science is stuck. Not so much because of lack of data, but because data is not being sought. I went to the expedition to the Pacific Ocean just a few months ago, looking for materials from an interstellar meteor. And what did the scientific community have to say? Those experts on rocks were just saying, why would you go there? You will not find anything. Then I found something. They said, you didn't find anything. And then I published results about it, and they said, no, this is not what you found. This has nothing to do with it. So it's all this negativity, this lack of curiosity is really striking me as destructive to innovation, to discovering something at the level of quantum mechanics. I'm really worried about that.
You mentioned the anomalies, that we are not seeking out the anomalies or not taking the anomalies seriously. What do you think are the key anomalies out there today that we are not looking at enough?
Well, one of them is what I'm studying, and that is unidentified phenomena, anomalous phenomena, it's called, by the US government. The US government is the most conservative organization you can think of. Their day job is national security. Yet there were hearings in the Congress and elsewhere about unidentified anomalous phenomena, things they don't understand. They would be the first to notice something unusual because astronomers are looking far away. Again, they're training their telescopes on objects that are already familiar, like galaxies, elementary particles, radiation and so forth. So they would not look for something unexpected if it flies overhead, whereas the US government needs to do that because maybe it's Chinese or Russian so they do it, and then they say, we don't understand some of the objects we are seeing. And no scientist, aside from the project that I'm trying to lead, the Galileo project, is really engaged in that. So that is one type of anomalies that I think is important to examine. And of course, separate from that, these are objects near Earth. But there are also interstellar objects. Over the past decade, we discovered the first 3 of them. And 2 out of the 3 looked anomalous. That was the meteor that I went after. It was tougher than all space rocks, all other meteors that NASA cataloged from the solar system. And it was moving very fast, faster than 95% of the stars near the sun. And then there was Oumuamua that was flat in its shape and pushed away from the sun by some mysterious force without showing cometary evaporation. So that was another unusual object. And the third one was completely familiar. That was a comet from interstellar space. These are the 3 interstellar objects we know about, all discovered over the past decade. That should excite us. We should say, okay, well, maybe if we monitor, objects that enter our backyard from the cosmic street, we might find a tennis ball thrown by a neighbor or something unusual. So again, the fact that we saw 2 that are anomalous to me is intriguing, but yet there is no money allocated to this study and no excitement within the scientific community to conduct it. And then, of course, there are other things that are anomalous. For example, there is most of the matter in the universe, 83%, is unknown. We've never witnessed it in the solar system. We call it dark matter. As far as I'm concerned, we don't even know whether it exists or whether gravity is modified. And if gravity is modified so that you don't have a new form of matter, it would have fundamental implications. Because it means that Einstein's theory of gravity is incorrect at very low acceleration. So that's another anomaly, that is currently we're stuck. We're searching for dark matter for 40, 50 years. We haven't found any clue. There were $10 billion invested in the Large Hadron Collider for the most popular dark matter particle, the lightest supersymmetric particle. Nothing was found. And nobody in the mainstream says, oh, well, it was a waste of money. No. But yet, it's still believed to be a very viable possibility. So I really think that we are stuck on a number of anomalies. We also don't know what happened before the Big Bang. We don't know what happens inside the black hole. These are serious questions. And we're moving in circles, that there is nothing in the foreseeable future that I can see that will break our ignorance on these questions, because the mainstream holds to ideas like string theory that we have no way of testing, that make no predictions in any realistic circumstance. And so if it doesn't make predictions, you can't test it. So I'm frustrated by the current culture within science and academia.
When I was very young, 23, 34, I was at CERN and I was helping design the data acquisition system for the Atlas detector. Atlas and CMS were the 2 experiments that found the Higgs in 2012. And back in 96, 97, when I was there, it was the beginning of the LHC project, the beginning of the Atlas. And the thing was pitched to the world as an attempt to find the Higgs boson. But of course, the previous accelerator, the LEP, much lower energy levels, but it had events that were consistent with the Higgs. We just didn't have 3 sigma statistics. We couldn't claim a discovery. But you just look at those histograms and you're like, well, this bump here ought to be a Higgs because it's right where we would expect to find it. So for me personally, my motivation was supersymmetry, SUSY, as we affectionately used to call it. I wanted to find SUSY desperately. And it was a big disappointment for me that it was not found, at least in the energy levels where we can look for it.
On this, I should tell you an anecdote just on supersymmetry before you continue. I had a lunch with a string theorist last year, and I asked him, what was your main accomplishment in physics? He's a string theorist, so it's just theoretical physics. And he said, well, it was a paper about supersymmetry. And I said, well, why would you be so proud of it? Because we haven't yet found supersymmetry, so maybe it's completely wrong. And he said, well, we didn't find it at CERN, but it may be just around the corner. Maybe when we increase the energy, we will find it. And that reminded me of the religious Orthodox community in Brooklyn, in Crown Heights, the Lubavitchers, because for decades they thought that the rabbi will become the Messiah. That was their model, the theoretical model. And then the idea is that when he dies, he will come back as the Messiah to Israel. So they built an apartment for him in Israel that is a replica of his apartment in Brooklyn, so that he would find the toilets easily when he comes back as the Messiah. And then he died. That was a data point, just like supersymmetry was not found by the Large Hadron Collider. And the question is, how did they adjust the theoretical model? Well, they said, okay, he died, he didn't come back as the Messiah, but we just have to wait. So now I ask you, what is the difference between a scientist that never accepts the verdict of an experiment because it can always be around the corner, and a belief, a religious belief, which says we just have to wait, the Messiah will come?
I completely agree with you, and it gives pain to me in my heart that I agree with you, because supersymmetry is just so enormously beautiful that when I was a young man, I thought something this beautiful, a very Platonic idea, something this beautiful must be true, because beauty is true. Plato said that 2,500 years ago. But I agree with you. That's not science. That's not physics. It's a kind of mathematical philosophy together with wishful thinking. It's a psychological thing. But don't we do more of it? I mean, we are doing this all the time. Look at the hard problem of consciousness. One day we will figure out how physical parameters can allow us to deduce the qualities of experience in principle. And it's always further ahead. But one day we will. Or another example, you referred to the entanglement experiments that won the Nobel Prize in Physics last year. The spooky action at a distance, which probably defy not only locality, but physical realism itself. There are still people saying, well, physical realism is still not refuted because there can be gazillions of inaccessible parallel universes where every experimental outcome actually happens. It's just that we can't access it. Isn't it the same kind of thing, the hard problem of consciousness, or using the Everettian many worlds interpretation to stick to physical realism? Aren't we doing the same thing? Well, one day we will solve an insoluble problem.
Right. With respect to consciousness, and there is also the issue of free will and so forth, I wonder whether artificial intelligence will help us in some sense, because if we will interact with a system that behaves just like humans in all possible ways, I mean, that we can fall in love with, that we can converse and it will surprise us, that it will create, let's say GPT-5 or 6 will start to create art in ways that appear to be new, that we haven't associated with anything before. So if a system like that, artificial system like that, starts to behave like a human, except for the physical interaction, it doesn't have a body. But in terms of all the mental states, then the question is, first of all, isn't that just showing that it's just a matter of complexity, that once you have a number of connections in an AI system that is equal to the number of synapses in the human brain, once you have that, or even a more complicated system, then it behaves like a human brain, and it's just a matter of complexity. Until now, we dealt with systems that are less complex than that. And that's why they didn't appear to have those qualities. So in a way, that would remove our sense of awe from what humans are able to do, because here is a system that we created and it's just complex enough to behave like the human brain. The second thing it can bring to the table is that we can do experiments with it, because now that you have a system that you created, I mean, you could potentially dissect it and start to explore it, just like you do an experiment in physics where, you isolate parts of it, you remove some abilities and you see whether it still is capable of doing what it does. And so it will give us an experimental test bed for checking what is really responsible for specific qualities that humans have. And In particular, I'm most curious about whether free will isn't just a sign of a system complex enough such that you can't figure out what it will do because it's complex. Now, of course, you don't want to tell people they don't have free will because, you want them to take responsibility for their actions. So you can still tell people, look, you have the choice of making a decision, but deep down, you will know that the system which makes the decision obviously is just complex. That's all. There is nothing like a soul. There is nothing extra beyond what physics gives us.
I personally think the whole discussion on free will is a red herring. I don't think there is semantic space between determination and randomness, which is where we try to find free will. Free will is not determined, but it's also not random. Well, that space doesn't exist. I think it's a red herring. The question of consciousness, I don't think is a red herring. I think it's a real one. The way you approached it by saying, well, if we produce a system whose structure is analogous to ours in some sense, at some level of abstraction. It's not a metabolizing system, so that analogy is based on some kind of abstraction. And if its behavior is like ours, then it's conscious. I don't think that line of inference exists. I don't think measurable behavior from the outside necessarily betrays the presence of conscious in their life. I can fake it. I can emulate behavior without emulating the cause of behavior. But the point I wanted to make, just before I will let you jump in immediately, but when you said it's a matter of producing more and more complex systems, and then we will get to a sort of a physicalist account of consciousness. Isn't that entirely analogous to the physicist who says supersymmetry, it's a matter of more and more energy. If we just add more energy, we will find supersymmetry. And you criticize that line of thinking. Aren't you guilty of the same line of thinking when you say it's just a question of complexity? When we get to enough complexity, boom, the answers will be there.
Well, I'm saying that we will know that because just wait for GPT-5, okay? And it's not a matter of my opinion. If you interact with GPT-5 and you can't distinguish between that, in fact, if it does better than humans in some ways, then I will know that we got there. But I have another point that I actually made in my recent book, Interstellar, which is look at Stephen Hawking. When he visited my home in 2016, he could not move a muscle except for his eyebrows. Okay, so here is a human, and by the way, just a few years before that, he flirted with one of the nurses that took care of him. So he had an affair. Okay, that shows you that he was human. When he visited, one evening, he communicated through his eyebrows that he said, after one of the events, he said, I'm bored. Let's go to the bar in the hotel and have some fun. Okay, so that shows you that he was human, but his physical abilities were diminished. I call that the Hawking limit. It's the limit where your body is not responding, is not functioning. Yet he was human. Why? Because his brain was still working. So I say, okay, take the Hawking limit to the limit where you can't move a muscle, okay? But you're still, you wouldn't argue that Hawking was not a human. Obviously, he was a human, right? You looked at him, you said, that's a human. He would express feelings like anyone, like any human. So I'm saying, okay, take that limit and apply it to GPT-5. No body. In that case, there is no body. So it's not a situation where the body degenerated and can't work anymore. If you look at it, it's just, made of silicon or metal, and so there was never a body there, a biological body. But it doesn't matter. When I take the limit of Hawking not being able to move anything, and I put that side to side with a silicon-based machine, AI GPT-5. Okay, so what is the difference if GPT-5 can flirt with the engineers that make it, and if it has humor, and if it writes equations and codes, Like, why would I call Hawking a human and GPT-5 not human?
I would interpret it differently. The fact that we know Stephen was conscious, and yet his behavior hardly betrayed it, because he wasn't able to manifest behavior that the rest of us are, shows that there is not always a reliable correlation between inner life and external behavior. In the case of Stephen, there was inner life and there was little external behavior. I would maintain that the symmetrical option is equally valid. You can have external behavior that is consistent with inner life, and yet there is no conscious inner life, because you cannot measure inner life directly. So that's how I would see that. I would see that as a reason to...
If I give you a robot that doesn't move a muscle and it has the thoughts of Stephen Hawking and beyond, why would you say it's not human?
My point is, Turing's test, which is an assessment of an entity based on its external behavior, can we distinguish it from an intelligent human or not? I think if an AI passes a Turing test, then it is intelligent. And it may be as intelligent as a human or more intelligent than a human. This I grant. What I don't grant, and I don't think it's a logical implication of the result, is that such intelligence is accompanied by inner experience the way yours and mine are. I think that's a separate thing.
Okay, so how do you tell the difference between a high-level GPT system and a Hawking body that doesn't move? How do you tell the difference?
I'll give you an answer that is so obvious you would think I'm being facetious, but I'm not. It's just that I think we do forget it. We tell the difference because Stephen Hawking was a metabolizing living organism that burned ATP, did protein folding, had brain activity based on the release of neurotransmitters across synaptic clefts. And ChatGPT is based on silicon, on oxides and metal, and instead of releasing neurotransmitters, it moves potentials, electric potentials. So they're completely different things, even if they manifest analogous external behavior. And then, depending on a definition of intelligence, including my own definition of intelligence, you could say, I define intelligence at such an abstract level as a clever manipulation of information.
What is your definition?
Intelligence is a clever manipulation of information to solve problems effectively and efficiently.
Okay, GPT-5 can do that.
Yes. So I think, well, I never used GPT-5. I'm a user of GPT-4.
It doesn't exist, but I'm just, yeah, right.
So I think it's intelligent, but I don't think intelligence betrays or even implies the presence of conscious inner life.
So how do you test for that?
It's impossible to objectively access the presence of conscious inner life in anything beyond ourselves, because structure and behavior can be emulated without the presence of conscious inner life. But nature gives us some hints, like the behavior of all living organisms is analogous at a certain level. Even single cellular organisms like amoeba. Amoeba build little shells, little houses out of mud particles at the bottom of the ponds where they live. Planaria can be trained to navigate mazes, and they're not unicellular, but they're very simple organisms with only a couple of thousand neurons. So, and at the same time, there's something else that unifies all life. It's not only that their external behavior is analogous. So if I am conscious and another living being manifests behaviors analogous to mine, then that suggests consciousness. But there is something else, which is metabolism is what unifies all life. At the microscopic level, all life is incredibly similar, if not identical. Everything does mitosis, everything does, not unicellular organisms, everything burns ATP, everything does protein folding.
Yeah, I agree with you. I agree that these are characteristics that are shared only by biological organisms. It's just that I'm not attached to them. To me, I just got my new iPhone yesterday, Pro Max 15, whatever. I'm more attached to that than to an amoeba. I really like technological gadgets, and the latest are the best. And I'm very proud of our technological kids, just the way I'm proud of my daughters. You know, I don't understand my daughters all the time, but I'm proud of them. And I hope they will be better than me. So if future LLM, large language model systems will do better than humans in pursuing science, I'm all for it. I'm all for sending AI astronauts rather than humans to space. I don't think we are the pinnacle of creation. We do horrible things. Just look around, the globe right now. There are two major wars, one in the Middle East, the other one in Ukraine. And what good does it serve? People are getting killed, and we are wasting resources, and we are creating misery. And if you just look, of course, I'm writing essays in medium.com, and one of the recent ones last week, in that one, I referred to the fact that, the messianic age that we talked about before, the age of the Messiah in Judaism is represented by a peace. Okay, that is the goal, to reach a peaceful future. And what we are trying to do in order to advance it, according to Judaism, one of the biggest mitzvahs is actually tikkun olam, is trying to repair the world. The world has so many faults. Let's repair it and bring the messianic age. And, peace is a sign of intelligence, because if you look at animals, they fight all the time for resources that are limited. But when you do science and technology, you create things that did not exist before, and so that it makes the zero-sum games that we are used to in biology. It changes them to an infinite-sum game where there is plenty for everyone. The age of science and technology makes much more than we actually need. And if everyone were to work together, we wouldn't have to work much, because robots and AI systems will do much of the labor that we currently do. And so the future of having peace and being relaxed and enjoying your existence, that kind of messianic future could be brought about by science and technology. And actually, my view is the Messiah will not come from Brooklyn, the way the Lubavitchers believed in. It will come from an exoplanet, because we would see a more advanced technological civilization. It's just like finding a smarter kid in our class and then realizing we can do better. That is my hope. If you ask me, my hope is to merge science and religion in such a way that the future, the messianic age, will come along with peace and prosperity as a result of us changing our ways, getting a wake-up call from another civilization that managed to do that. And they, tell us, look, there is a better way. You are acting like primates. You are acting like biological. And to me, if we end up with a future that is dominated by technological kids, like we were discussing, I don't care, about defining consciousness and defining what biology can do for you, because biology, at least according to science, came about randomly out of a soup of chemicals on Earth. And it's not the pinnacle of creation. It's not really the best you can hope for. You look at the atrocities around the world, the bad things that humans do. It's really bad. And I can imagine systems that are better than us, that we created, that help us be better. And so maybe AI, for me, is a way for us to save us from ourselves.
I agree with a lot of what you said. I am very invested in technology development. I worked at it for 25 years. I left the industry recently, a couple of years ago, but I gave 25 years of my life to it. But I still do technology. I can even show you. This is my latest little project. This is Bernardo's supercomputer. It's just an educational project for fun and to help students understand parallel computers. So I'm very invested in it. I worked in AI for several years. I even did AI while I was at CERN. We were supposed, at CERN, at the LHC, at the Atlas, we have one event, one impact on average every 25 nanoseconds. That's an event, and it produces a huge ocean of data. It's impossible to store everything. So you need to take a intelligent decision automatically every 25 nanoseconds to decide, is this potential new physics or is this old physics? If it's old, you don't store it. If it's new, then you put it in the hard disk drives for offline analysis. And we had to discard like 98% of the data because the Atlas produces many terabytes of data every second. And we did that decision based on classical physics algorithms that were based on the understanding of physics. But illicitly, in parallel, in our own time, we built convolutional neural networks to do the same. And guess what? They were just as good as the physics algorithms. Of course, physicists chose to use the one that they understand as opposed to the black box of a convolutional neural network. We didn't have visualization tools like today back in the late 90s. So it was very hard to understand what the thing was doing, and it leads to uncertainty. I am a believer in strong AI. I think artificial intelligence beyond human level is an inevitability, and it's not long term. It's going to happen in our lifetimes. What I don't think, though, is that the evolution of AI, the evolution of our ability to compute cleverly, will, in any sense, enable a solution to the hard problem of consciousness in physicalist terms. I think that problem is
remains to be seen. That remains to be seen. But one thing about the AI, a lot of people are worried and afraid. There was this letter signed some months ago about the concern for an existential risk, if you remember that. Mm-hmm. And I thought these people just don't know how to be good parents. Because, when you deal with intelligent beings, that's the same as being a parent of an intelligent baby, So how do you deal with that? You don't know if the baby will become a criminal in the future, and you worry about that. And so the first thing you do is, first of all, not expose the baby to all the crimes that happen in the corners of, dark corners in the street. You just don't do that. And if you take an AI system and train it on all the dark corners of the internet, that's not a good idea. Okay, you want to educate it to follow the guiding principles that you believe in, and rather than expose it to all the crap that it can find at random places. And so that's what you do with children. That's called education. And so the point is, dealing with AI systems, physicists are not really equipped to do that because they are not used to dealing with intelligent objects. They're used to dealing with electrons, protons, particles that have no personality, no intelligence. Whereas psychologists and philosophers are used to that. So I think it's really the role of the humanities to educate us what are the best principles that we should use in dealing with artificial intelligent systems that go beyond us. And I think, and I call it humanities of the future, because unfortunately, if I look at the courses being offered at universities, they are mostly in philosophy. They are mostly focused on ancient Greeks and things that statements that were made when computers were never available, and that to me is old-fashioned. I would much rather have our philosophers and psychologists address how to adapt to AI in the future. So I call that humanities of the future. They can become relevant. People in the humanities are often arguing that there is not enough resources, not much attention, and they don't get their share in academia. And I say, well, you need to adapt to changing circumstances. You can't keep teaching Aristotle. Sorry about that, Phidias, ancient Greek. You can't keep, of course, Plato and Socrates, they were very smart people. But the point is they didn't have, cell phones. They didn't have computers. So they couldn't have made any statement on these and how to adapt to those. And that's the role of people who have a profession to consider intelligent objects, intelligent entities like humans. And so now, instead of just dealing with humans, they have to deal with artificial intelligence. And I think that would be the humanities of the future.
I agree with you that AI safety is no different than the safety of a nuclear power station. It's a question of engineering, and it can be professionally dealt with, and it can be rendered very safe. Let me try to ask you something else. In the very beginning of our conversation, you alluded to the experiments that won the Nobel Prize in Physics last year, 2022, Anton Zeilinger and Alan Aspect. I forgot the third one from California. Some would say that what those experiments have refuted is that the universe can be both local, in other words, causality obeying the speed of light, and physically real, in the sense that physical entities are supposed to have standalone existence independent of observation. So you cannot have both at the same time, but you can still have either one of them. You can still have a non-local universe, or you can still have a physically non-real but local universe. But work done at the IQOQI in Vienna, the Institute of Quantum Optics and Quantum Information, the Institute of Anton Zeilinger, they've used, back in 2007, Tony Leggett's inequalities, which are different from Bell's inequalities. Bell's inequalities cannot differentiate between locality and physical realism, but Tony Leggett published this paper in 2003 in Foundations of Physics, proposing inequalities that can make that differentiation. And the inequalities related to physical realism were experimentally demonstrated. Those demonstrations are part of those 40 years of empirical results that won the Nobel Prize. And except for perhaps pilot wave theory, which is not plausible for a number of other reasons. It doesn't have relativistic extension. It contradicts quantum field theory in imagining particles to have discrete spatial boundaries as opposed to being field excitations. Except for that, it discarded the largest class of non-local hidden variables theories that could preserve physical realism. So I would say those experiments have refuted physical realism. Do you agree with this? And if you don't, why?
Yeah, no, I think there is a real problem in the interpretation of quantum mechanics. And my guess, and this is just a guess, is that it's because we don't have a good understanding of how to unify quantum mechanics and gravity. Okay, so that's the fundamental problem, because it's right now quantum mechanics is formulated in a background space-time. And according to Einstein, space-time itself responds to the existence of matter, and it's being curved by matter. But we don't have a theory that at the same time, allows space-time to behave in ways consistent with a quantum mechanical description of how matter behaves. And so quantum mechanics as of now is formulated given that the space-time is prescribed in advance. And the space-time that is prescribed in advance is prescribed based on classical physics, not based on quantum mechanics, because Einstein's theory of gravity tells us how to do that. And my guess is it's quite possible, in my view, that that the approach taken by theoretical physicists for the past century, I mean, starting with Einstein, is just wrong. I mean, they try to, in various ways, to imagine extra dimensions and try to unify the two in extra dimensions, but still, space-time itself is not is behaving differently than than we are usually describing it. So it may well be that we don't understand how space and time behave quantum mechanically correctly. And once we will have a sense of how space and time respond to quantum mechanics, and everything is put together in a consistent framework, we would realize that the interpretation of quantum mechanics is a different one. And so we are stuck because right now we're thinking of space-time as being given to us externally, unrelated to quantum mechanics. That's why we are stuck with the interpretations of quantum mechanics. I wouldn't be surprised if that's the reason for the current confusion that we have. But as to what is the solution, I don't know. But all it says is that, quantum mechanics and general relativity are the two pillars of modern physics. The fact that we don't have them unified is a big problem. And what I would argue is that we are probably not doing it the right way as of now, because it doesn't, the attempts like string theory doesn't really resolve the issues with interpretation of quantum mechanics. So we really need a different way of thinking of this.
Do you believe physical realism is the case? Do you believe that elementary physical entities have standalone existence independent of measurement?
No, it's just in the limit of h bar being zero, or when you have a big enough system such that it behaves classically, that indeed I think that's the case. So, and that's the limit where quantum mechanics goes to classical physics. And we all know that classical physics works very well. Astronomers deal with the motion of stars, the motion of planets, very precisely, to many significant digits. And the same about the expansion of the universe. You don't hear about quantum effects coming into play in cosmological measurements as of now. And so the reason is that these are big enough systems where quantum mechanics plays a negligible role. But in that limit, indeed, the realism is valid. And that's the sense of realism that we have in our daily life, because when we drive a car, when we interact with people, these are big objects where h bar is not really important. And so when you go to the level where h bar plays a role, like small elementary particles or systems that are in a coherent state, then it starts, your question becomes relevant. And there, I don't think realism necessarily holds the way we think about it. So now how to interpret what is happening, requires a unified theory, and that's what we don't have.
I was trying to explore our differences, but we don't have many.
Right.
So there is a question I always wanted to ask you, and I'm not going to ask you that question to put you on the spot. That's not the spirit. It's that I believe in the work you did regarding Oumuamua, and so this is a sincere question. It's not rhetorical. It's not. I don't have an agenda other than to truly understand what you think. There has been this paper published by some of your opponents saying that there are other 6 objects in the solar system that exhibit that anomalous acceleration that was exhibited by Oumuamua. And we have photographs of those objects, and one of them is going to be visited by a probe in a few years. What is your reply to that?
Oh, no. I mean, if you look, I think this is just dishonest to say that it's the same as Oumuamua. It's a question of magnitude. So the claim is there are dark comets. Okay. So a comet is defined by the fact that you see a cometary tail. You see evaporation from it. Now, obviously, if you have no evaporation, then you won't see a tail, a cometary evaporation. But you can dial the evaporation down by orders of magnitude to the level where you can't see it. So effectively, there is a cometary tail, but it's the evaporation rate is so small that you can't see it. Okay. So these are the objects that they're talking about. So I know exactly, I checked the paper. So here is what I go to that paper that was published claiming there are dark comets. And I look at the plot where they show the mass loss rate of those comets, how much mass is getting evaporated per unit time. And it's orders of magnitude below what is needed for to explain Oumuamua's propulsion. So obviously, if you dial down the evaporation rate such that there would be so little mass evaporating, you won't see it. You won't see it. So it's a dark comet. I agree. There could be dark comets. It's, you can ask, okay, suppose we go back to the tale by Hans Christian Andersen. The emperor has no clothes. Okay. That's what the kid said. That's what I said. I said, Oumuamua has no cometary tail. In the case of Hans Christian Andersen, the kid said the emperor has no clothes. Now, the emperor didn't have any clothes. The emperor was naked. Okay. In the tale. But the adults in the room, like my colleagues, they are saying, oh no, there are clothes. They are just invisible. Okay. So the dark comet idea is there is so now, of course, you can have something in between where the emperor has transparent clothes, clothes that are extremely thin, made of nylon, and you can see through them. And the kid would say the emperor has no clothes. The adults would say, well, of course the emperor has clothes. But the point is, if they're so thin that you can see through the clothes, it's not really clothes, okay? So the kid was right. And so when you deal with dark comets, it's a question of magnitude of evaporation. And if the evaporation is so small, I ask those people that write this paper, of course, you can pretend that they are comets and they are dark, and Oumuamua was dark, therefore it could have been a comet in principle. That's not a philosophical question. Just take the evaporation rate required to explain Oumuamua's propulsion and ask for that evaporation rate, will the cometary tail be invisible? And the answer is definitely not, because it's orders of magnitude. I calculate, it's like 4 to 6 orders. It's like a factor of 10,000 to a million, more evaporation that you need. And when you put that factor in, it will not be a dark comet. So what are they talking? I mean, this is like cheating, and so there was another claim. Maybe Oumuamua is just an water ice, comet. Now, a water ice comet is the comets that we see. So they said, no, Oumuamua was also a water ice comet. The only difference is that it was an iceberg of water that went through interstellar space and was exposed to cosmic rays. And I say, well, the Oort cloud comets, the comets that come from the Oort cloud, they are outside the protection of the solar wind, which stops at the heliosphere. They are just exposed to the same cosmic rays of interstellar space as icebergs going through interstellar space. Exactly the same. And we see such comets. And they show cometary tail. That's the whole point. So now you're telling me, from interstellar space, we have water icebergs that are transformed in ways that the Oort cloud icebergs are not. I say, okay, well, let's check the numbers. So I check their paper. And by the way, it's the same person who wrote that paper as argues about the dark comets. I check the paper and I find a mistake by a factor of 1 million. In the energy
that was the first paper.
In the energy equation. I point this out, and we published a paper showing that they made a mistake. That's all. So the point is, people are making all kinds of claims, which are not really honest, and this has been going on for 6 years now, since Oumuamua was discovered. And I asked, so the point is, there was even a blog post saying Oumuamua was nothing unusual, a big blog post by other astronomers. And I said, okay, well, how do you explain the fact that there were at least 3 independent groups of astronomers publishing half a dozen papers trying to explain one of the anomalies of Oumuamua, if it was obvious from the beginning that it's natural? It's really disingenuous of people to claim, there is no problem, after there is so much literature of other people trying to solve the problem. And so I'm not saying it's artificial necessarily. I'm saying let's stay curious. That's what I was talking about before. Even when I went to the expedition, the same people who claimed Oumuamua was nothing also claimed you will find nothing. You didn't find anything. And by the way, the government measurements were wrong. It's all negativity. And if instead of being negative and injecting poison into innovation, if instead of doing that, they would say, okay, well, let's consider the possibility that this was an interstellar object. Let's ask, what are the consequences? They would write up the paper that I just posted this week, which explains the properties of this interstellar meteor as coming from dwarf stars. just like Proxima Centauri, the most common types of stars. This is a beautiful paper. We just posted it on the archive last night. Explains all the properties of this interstellar meteor in terms of its composition, high speed, in terms of its material strength, and its abundance. All of these come together beautifully. The numbers just drop out of the scenario that we talked about in the context of dwarf stars. And I just say the same people who chase me and say bad things and try, tell reporters that they are sick and tired of reviewing my papers. Like what? That's the scientific process. I mean, I'm submitting a scientific paper and nobody is sick and tired. It's just this particular individual that, frankly, I would advise him to have a better therapist because he should not be, I mean, I wish him prosperity. I don't wish him anything, like why would he be so annoyed of the scientific process where there is a scientific paper sent out to being refereed? Like this is the way we do science all the time. And the point is, instead of injecting negativity, if that person were to think constructively, he could have written my paper, the one that I posted last night, because it's a very beautiful model to explain the properties of this interstellar object. And instead, he was just saying bad things to reporters in the New York Times Magazine profile. And I think it all stems from jealousy. If you ask me, the fact, the New York Times Magazine never had a profile of a scientist in recent decades. And there was also on medium.com, I put last night a Q&A with Rolf Dobelli from Die Welt. He published it in a German magazine, a Q&A, which I recommend for people to read because it's just showing how much the public is interested, how much everyone cares. And it's just those, mobs from academia that are populated by scientists who are not really first class. They're not really the best scientists that I can speak with. And they are, giving a bad reputation to science because what they are doing is they are suppressing the scientific curiosity, which is based on seeking evidence, collecting materials, analyzing them in the lab. That's what I'm doing. It's a lot of work, but it's very easy to be opinionated. It's very easy to just sit on your chair and say bad things about people. The way that a lot of people do on social media, it's just negativity that doesn't serve any good purpose. And once again, it's a trait of humans that I really don't like because it doesn't help us in any way. It doesn't promote new knowledge. And the first time where I faced it was as a kid, when I would ask a difficult question and the adults in the room would dismiss it just because they didn't know the answer. And nothing really changed. Now I have tenure, former chair of the astronomy department at Harvard for a decade. And, I'm just pursuing innocently, really. I'm doing my best, putting a lot of my time, months and months of work to writing scientific papers. And all these people have to say was negative remarks to reporters. I mean, I just find this counter-scientific. They are not really scientists. They are not curious. One of them told me, Oumuamua is so weird. I wish it never existed. And that to me shows that this person is not a scientist because he could have said, Oumuamua is so weird. I'm really curious to figure out what it is.
Yeah, that's the scientific attitude. Yeah, I completely agree with you. I'm happy you had the opportunity to say everything you've just said on Phidias podcast that will be seen by a lot of people. So I feel very happy about it. Avi, you are not alone. This is human stuff. Science is done by humans, and that's how it goes. I was in the Venice Lagoon not long ago.
Yeah.
You wanted to say something?
I just wanted to say that this weekend I came back from Italy and there was a group of 600 students who gave me an award. I don't know if you can see it. It's just behind me here. It's called the Cosmos Award. You can see the spiral arms. And I was really honored by that because young people are still curious. I have trust in the next generation. And I said, I'm so honored to be given this award by young students rather than a committee of senior people. And so the senior people in the first row were not happy about what I said, but that is what I believe in. And, when I went to get my new iPhone, it was the first time after the pandemic that I went to a public store, the Apple store. I didn't go until to buy anything out because everything is delivered now with Amazon and so forth. So I went to a public store. I stepped into the store, and within a few minutes, someone came to me and said, "Are you Avi Loeb?" And I said, "Yes." And that was a young person. He said, "Can I have a picture with you?" And I said, "Sure. And thank you for pursuing what we are all curious about." That's what he said. And to me, that was such a delightful moment that, the trust that young people have in staying, genuine and curious and not subscribing to be the adults in the room. That's my advice to young people. Never become the adults in the room.
That's the scientific attitude. Always learning, always discovering. I was telling you, a few weeks ago, I was in a small island in the Venice Lagoon, San Servolo, for a sort of a meeting of people involved with the integrated information theory of consciousness. Giulio Tononi, Christoph Koch, a lot of other people were there. A few dozen people, couple of dozen people. And the very last day of our meeting, there was a highly politicized letter published on the Psi Archive, which is the archive of the neuroscience community, accusing integrated information theory of being unprovable pseudoscience.
I saw that, but it was just jealousy that it got attention.
Yeah. Well, I think there's more than it's even worse than just jealousy, because if you read the letter, it's 3 paragraphs that are completely devoid of scientific substance. And let's start from the fact that it's an open letter. Scientists don't communicate with one another via open letters. Open letters are used when scientists want to communicate to the people or to the government, not to one another. To one another, it's scientific, peer-reviewed academic papers. But if you read the content, 3 short paragraphs, no scientific content, just accusations, a lot of authors, but it will get a lot of citations, Avi. It will be on the Psi Archive, not peer-reviewed, but it will get a lot of citations, a lot of attention, and their H indices will climb prodigiously, very quickly. And yeah, that's the politics of humans, even when humans are doing science. I hope you don't get discouraged by this, and you keep on going.
Yeah, I mean, so far so good, because for every negative remark, I get a lot of positives. So there was a few weeks ago, we had a play called The Piece of Sky presented at my home, and it was written by a playwright from Los Angeles, who again was inspired by the search for extraterrestrial intelligence. And so I see a lot of artists that are encouraged as well by this work. And it's sort of, I feel that if I give up on this, I will disappoint a lot of people that are really curious about it. My hope is that it will catch up and there will be more engaged. And the biggest damage that I see to people like the people that attack me or attack the actual research is that the young people, young scientists who are worried about getting a job, they see this as a signal to tell them, stay within the beaten path, do not deviate.
Yeah.
And unfortunately, if you want to find low-hanging fruit, the best place to find low-hanging fruit is in the path that was not taken, because nobody picked them up. And so once again, if we continue to discourage young people from deviating from the beaten path, we will not find any low-hanging fruit. And so I feel that, and the other thing is that there are people within the general public that are really excited, that are wealthy, and so far I benefited from their generosity. The funding of the expedition was $1.5 million. And so gladly there are people who believe in this path and they are funding the research.
Avi, what do you think is going on when you look at the phenomenon and you take into account David Grush, your own research, Oumuamua, perhaps the more counterintuitive work of Jacques Vallée, which is very well substantiated. I mean, whether you agree with him or not, I mean, he has done excellent work over decades. If you bring all of this together, including the Magonia hypothesis, and you take all of this into account, what do you think is going on without scientific rigor, just from a human perspective? What do you as a human suspect or think or speculate is going on?
Yeah, so I respond to evidence. You see, I prefer not to imagine things. I just want to follow, just like a detective. It's a detective story. You want to collect as much evidence as possible and figure out what it means. Okay, and that is the way I think about it. I find it very intriguing. All of these clues appear to point that there is something unusual going on. Okay. Other people within academia say, oh, extraordinary claims require extraordinary evidence. But my point is, the evidence doesn't fall into your lap. You have to seek it. And it requires a lot of work. So extraordinary evidence requires extraordinary funding. And the good news is the sky is not classified. The oceans are not classified. So we can do the research. And it's a circular argument to say we don't have the evidence yet to get engaged. Because if we were to say that about gravitational waves or about the Higgs boson, we would never discover it. It's just because billions of dollars were invested and people dedicated decades of research that we found those things. So you can't just say, that dark matter is an extraordinary claim that doesn't have any substantiation. You just have to go into a dark research area that we don't have any clue about and see whether you find anything. And that requires effort, that requires funding. So scientific research is all about exploring the unknown, and sometimes you fail, sometimes you succeed, but not engaging in the search and claiming you don't have evidence is really a circular argument, an unfortunate one, because the public cares a lot about it. So I do think Grush told the truth. He heard things from people that he spoke with. The question is whether it was a fabricated story by those people who told him things. And, I can imagine the US government developing very advanced technologies and just saying, oh, this is alien technology, just to divert attention from the fact that it's all human made. But it's also possible that they did find something and it's hidden. And what Grush was saying is correct. And so I don't know, because I haven't seen the evidence. He didn't see the evidence. So we can, there are two approaches you can take, just like in the Samuel Beckett's play, Waiting for Godot. You can keep waiting. Okay. You can keep waiting for the government to declassify the information, show you the material. But according to Samuel Beckett, you will wait forever. And the other approach is to say, the hell with it. I mean, why do I need the government to tell me what happens outside the solar system? Like, we don't do that in the context of cosmology, in the context of astronomy. We don't ask President Biden to tell us what a red giant would do late in its evolution. Like, this is not what Biden works on. And so why should we wait for the government to tell us what is in our sky? What kind of interstellar objects are visiting us? We don't need to. Just forget about the government. Who cares about the government? Anything that says made in China is very boring. Like, why would we care about that? What we want is to see something that says made on an exoplanet. That would be exciting. So let's explore it ourselves. Let's look at the sky. Let's search the ocean and figure out whether there are interstellar objects that are technological in origin, searching for a technological needle in a haystack of rocks. Now, of course, there will be those people who worked on rocks for decades, and they will say everything in the sky is stones. And I call that the stone age of science. When you say everything in the sky is stones. We should go beyond that. And to all the naysayers, we should say, okay, sit in your corner and complain. We don't care about you. We want to figure out if there is something unusual. That's what we should do. And that's what I'm trying to do. If you mud wrestle, you get dirty. If I go and argue with those people who say you will not find anything, I'll waste my time. And I prefer to take the approach of the eagle. When the eagle has a crow on its back and the crow is pecking on its neck, the eagle is not wasting time, fighting the crow. The eagle rises to greater heights where the oxygen level is low and the crow just drops off. And so I hope that by doing the science, it's just like going to my greatest heights, that all these crows that are pecking at my neck will drop off. It's not easy, but I hope that eventually they will.
What a beautiful analogy.
I just wanted to ask you one more thing, Avi, if I may. Fidias, may I?
Yes, you make a better interviewer than me, so I'm very happy.
It's not every day I get a chance to, sit with Avi. When we met for the first time, Avi, informally, the first thing you said to me was, Bernardo, what if God is an alien? And that that took me aback. I was like, whoa, well, where did that one come from?
Well, it comes from the hope of unifying religion with science. That's what I believe in. Because if you think about Moses, in the Old Testament, the Bible, Moses witnessed the burning bush. That was a bush that was never consumed, and that served as a miracle that convinced Moses that there is a superhuman entity, God. Now, if I were next to Moses with the infrared cameras that the Galileo project has, I would measure the temperature of the bush. I would measure how much energy is radiated per unit time, all the physical properties. And I could advise Moses whether indeed the bush is not natural and whether he should believe in a superhuman entity that created it. If you think about it, with our technologies, we can buy on Amazon, something that will burn up. And for Moses, it would have appeared to be a miracle. So the lesson of this, the moral of this story is that with sufficiently advanced technologies, you can create miracles for people who are not familiar with those technologies. Okay. And that includes better understanding of science, as we were discussing before, better understanding quantum mechanics, gravity, and so forth. So in the limit, once again, I like to take limits, just the way we did with Hawking, take the limit of a civilization that is billions of years more advanced than we are technologically. They would be a good approximation to God. In some sense, because they could potentially create life in the laboratory. They might even be able to create a baby universe in the laboratory if they understand how to unify quantum mechanics and gravity. I was talking about that just a few days ago at Harvard's Hillel. They invited me to speak to young students, Harvard students, who are interested in spirituality. And the subject that I chose to discuss is, can we create a baby universe in the laboratory? And what would be the implications? Because to me, if we were to mature technologically and scientifically, let's say in the next billion years, we might be able to do things that we assign to God. And so this is a framework for unifying. If a civilization can create a universe out of nothing, and then, as far as I'm concerned, it will fulfill the job requirements for being God.
Fantastic.
So
Fidias, I'm not going to stop you.
No. I love every question that you did, Bernardo. So this is similar to the simulation theory, or this is like something different?
It's different because it's, okay, the way I think of simulation is that nothing is real, that it's all a mental picture that is created by, let's say, a computer, or it's not real. But what I'm talking about is actually having a civilization out there in three-dimensional space and time, which is concentrating energy in a small enough volume to create a baby universe inside of which, there are things like us, which in principle is potentially possible. So I'm talking about reality, not about a simulation where things are not real. And frankly, I think it's irresponsible to believe. I mean, believing in a simulation is just like being high on drugs or putting the goggles of the metaverse, because you are not engaged with the reality that we all share. I'm not advocating for that. I'm saying the reality that we all share is real. It's just that there is a neighbor on our cosmic street who is far more advanced than we are. And that neighbor fulfills the job description of God.
Now, this should be a clip to be published on its own merit, videos. The way Avi distinguished between a level of artificiality in our environment, but without withdrawing reality from it.
Right.
And
it's part of
important
reality.
To make that, yeah.
It's just like we are able to create a television. Okay. So the television shows images. It's part of reality. The fact that the television exists, right? It's not as if this is simulated. I mean, of course you can. So let me explain in a better way what I mean by the difference between virtual reality and reality. You know about string theory, right? Okay. So now suppose I had a plumber that came to my home and I say, can you fix the toilet? And the plumber says, it's too difficult for me. And then I say, okay, well, can you please fix the pipe that leads to the faucet? It seems to be broken. It's leaking. And the plumber says, no, that's also too difficult for me. But then the plumber says, if you put goggles on your head, those goggles that Mark Zuckerberg made, then in the metaverse, I'm an exceptional plumber. I can solve all your problems. I say, thank you very much, and close the door and let him go. I don't pay that guy. Now, what do string theories say? So that's my definition of the difference between reality and virtual reality, because the faucet still leaks and the toilet still doesn't work, in the reality that I share. I don't care about putting goggles on my head because I want to solve those problems. And so we have two problems. We don't know what happened before the Big Bang. So I ask a string theorist, can you tell me what happened before the Big Bang? Because that's a singularity. You're supposed to unify quantum mechanics and gravity. Well, the whole purpose is to tell me what happened before. The singularities are supposed to be replaced by something else in string theory. So he told me, no, it's too difficult. And then I say, okay, well, I have another problem. What happens inside a black hole? There is a singularity there. And the string theorist says, sorry, I can't solve this problem. But then the string theorist says, if you imagine there are extra dimensions and we live in those extra dimensions, there are some problems in those extra dimensions that I can use mathematics to solve. And I say, thank you very much. That's not what I was after.
Yeah.
Okay. So that's the difference between virtual reality and reality.
Wouldn't Everett's many worlds interpretation fall into that category as well? It's like it's a non-empirical.
Oh no, because you can do an experiment. So if you were to imagine that there are many worlds, the many worlds interpretation, that we are bifurcating, that every time there is an event, it can have multiple outcomes according to quantum mechanics, and we happen to live in one of them, but we are not witnessing the others. If you were to believe in that, so you can do the following experiment. You can take a gun. Okay, point it at your head and pull the trigger, and it has bullets in it, but you don't know whether it's now. According to quantum mechanics, there is some probability that when you pull the trigger, it will not work. That in fact there will not be a bullet shot out of the gun, and as a human being, you will live in the reality that is allowing that. So if you keep pulling the trigger again and again, and you're always alive, then you know that the many world interpretation is correct, right?
That experiment will not pass the ethics committee.
No, but I'm saying there is an experiment where you will always be alive, irrespective of how many times you pull the trigger, because those are the realities that allow you to recognize that you're still there. And so, I mean, you can probably refine this experiment and do something that is less cruel than that. But the idea is that you can test it, this idea of many worlds, because you will, if you are allowed to exist only in a specific type of circumstances, you can see if those circumstances keep repeating.
But wouldn't it be the same as shooting a bullet through a brick wall? According to quantum mechanics, there is a impossibly small probability that the bullet will go through without causing damage.
Right.
So you don't need to shoot yourself. Shoot at a wall.
Yeah.
And if the bullet passes through...
Okay. So the point is that according to quantum mechanics, the likelihood for that happening is extremely small. So you will need to do a huge number of experiments before you see one. So in other words, if your existence is not conditioned on the outcome of the experiment, then you just have to do a huge number of experiments. If your existence is conditioned that the experiment will turn one way, even if this probability is extremely small, you will only exist in that option.
Yeah.
And that's how you test it.
But I mean, you're saying this half jokingly, but do you actually think this is a experiment that brings Everettian many worlds to the empirical domain as opposed to pure theoretical abstraction?
Well, it reminds me of another experiment that I suggested. We had a conference at the Black Hole Initiative that I was the founding director of. And in that conference, I said, well, there were talks by string theorists that were talking about, black holes and so forth. And I said, well, maybe in the next conference, we should organize a trip to a nearby black hole. And because that would offer the string theorists a test bed. If they enter the black hole, they can test near the singularity the validity of various models that they have. And so Nimar Kani Hamed was in the audience, and he shouted from the back of the room, "You have an ulterior motive of sending us string theorists into a black hole."
Get rid of them all. Cool.
I did not deny that.
So I guess the silence allow me to talk.
Yeah, I'm doing my best.
But I'm curious to see, Bernardo was taking the position of asking all these questions. I'm curious to see whether he agrees or not with what Avi Loeb is saying.
Whether I agree with what Avi said?
Yes.
I think a lot of what he said makes a lot of sense. I am satisfied with his reply regarding the paper about the other 6 objects in the solar system that have unaccounted for acceleration. I think that answer is completely satisfying. I am open to the possibility of non-human intelligence. I think ultimately Avi also agreed that intelligence and consciousness are 2 different things. In the beginning of the conversation, we were sort of conflating the 2, but at some point it became clear that, okay, we are talking about 2 different things. And then a lot of what he said, I think, is entirely reasonable. And I'm particularly impressed, maybe it's the right word, with his call for experimentation and then the collection of evidence, as opposed to rejecting certain avenues of investigation because of unexamined theoretical or metaphysical prejudices. That's not how science should progress. We should not discard hypotheses because they don't fit with our model of the world. It is our model of the world that should be calibrated by evidence, not the other way around. This is, however, very difficult to accomplish because we are humans. And there is this wonderful book from 1961 called The Structure of Scientific Revolutions, where Thomas Kuhn, he basically explained that for human scientists, and until we have an AI that can do science, that's the game we have, human scientists. For us, there is never neutral evidence. When you gather evidence, you already automatically couch the evidence in the framework of a particular interpretation. it's very difficult for humans to look at evidence in a neutral, unprejudiced way. And this can be traced back throughout the history of science, that this has happened again and again and again. And I think the same is at play with Avi's metal balls that he collected from the bottom of the ocean. There is a tendency for people to already bring in their own theoretical model, framework, prejudices to bear on the evidence before the evidence is given a fair, neutral hearing. So this is not a new problem, but it's important that we keep on talking about it and keep on pointing at this every time it happens, because although it has been around forever, it's not something that should be accepted. The only way to go forward is to keep on pointing this out with inner serenity, because if we start getting too emotionally taken by this, then we go nuts, or we retire. We just stop doing the work, because this is everywhere. But with that inner serenity to keep on pointing this out, like Avi has been doing, I think it's very important to do that. I'm not going to portray myself as victim here, but I recognize what the attitude Avi was talking about. It has happened to me for the past 15 years. It's a very recognizable thing, and we should keep on pointing it out. Unfortunately, we live in a society where you need to have tenure, or you need to be emeritus for you to be able to do that with safety. There are lots of people out there who maybe are suffering more from this than Avi and I put together, but they are in their 30s. And tenure is not around the corner, and they fear for their livelihoods. Because today science and philosophy are professions. We get yearly performance reviews. We need to publish a certain number of papers every year. We get appraised, salary appraisals. And that's the environment where scientists and philosophers need to survive and put food on the table for their families, their kids. And that's tricky. You know, in the old days in classical Greece, philosophy was patronized, not patronized in a bad sense, but philosophers had patrons, and philosophers and scientists were one and the same category, and they had patrons, and they had freedom to do what they thought was best and to communicate the opinions they thought were right. For us today, it's more complicated. In the framework of capitalism and having to earn a living, it gets more complicated, and subjects that have so much prejudice attached to it, such as non-human intelligence, they are favorite targets. And as my own subject is, I do metaphysics. And when I say metaphysics, I mean it technically. What is the nature of reality? What is the essence of being? That's what I mean by metaphysics. And I'm not a physicalist, which is the mainstream metaphysical view in our society. I'm an idealist. I think there is a world out there that is real. It doesn't depend on our observation, but it's not physical in the sense of not being amenable to description through physical quantities. I think it's a fundamentally qualitative world, and physics is the result of our measuring it. That's what physics describes. Physics describes a representation of the world, not the world as it is in itself. And although this is a vision I arrived at, a view I arrived at through reasoning and evidence, it has been historically associated with Bishop Berkeley and the church, or Hegel and his obscurantism. And I get a lot of flack for that. Most people who hear me, they don't hear what I'm saying. They hear what they think I should be saying because I am an idealist. and that's what they proceed to burn down. They burn down the straw man. So I sympathize. I feel a lot for what Avi is going through, because that has been my life for the past 15 years.
But by the way, Bernardo, I should say also that Steven Weinberg, the Nobel laureate, the celebrated scientist of the 20th century, he, at the end of his book, the first 3 minutes, he says, the more we understand the universe, the more pointless it looks. And the way I interpret that is that our colleagues who focus on lifeless entities like elementary particles, stars, dark matter, radiation, and so forth, these are entities that do not have life. And the one thing I learned through my life is, when you find a partner, it gives a meaning to your existence. And so what is missing as of now is for us to find a partner in the universe, because once we find an intelligent civilization out there, we would not feel lonely anymore. And we could ask questions, we can learn from them, we would have a relationship. And then the universe will not appear to be pointless anymore. That's the way the romantic interpretation that I see. And that's why I'm hopeful. You see, the fundamental question is, we all know that the world needs to be repaired, that it's really bad, okay? That there are lots of things that make us upset. The question is whether to be an optimist or just say, the hell with it. I just take a vacation and ignore the rest of the world. My approach is to be an optimist. And the reason is that sometimes life is a self-fulfilling prophecy. Because if I were not to go to the expedition and listen to all the critics, I would not search anything and I would not find anything. And the fact that I went there and found something that we are now analyzing at Harvard, is a result of believing that we might find something. So being an optimist really helps in making the world better. That's my approach. Are you optimistic or pessimistic about our future?
You irradiate your optimism. It's on your face. It's in the way you move. And not only in this conversation, every interview you give, you irradiate that. And I find that wonderful. And it's a unique thing. Most humans don't have that. You have it. You probably don't know you have it because you take it for granted. It's how you are. It's how you have ever been. It's the same face you see in the mirror every day since you're a kid. So, but you do have it. I think your analogy about finding a partner is beautiful and deeply moving. You make me optimistic at this very point right now. I don't know whether I am by nature as optimistic as you are. I do have a sense of meaning in my life, and I don't know where it comes from. I can't give you a nice, closed, intellectually satisfying account for where it comes from. I don't know, but I've always had it, and I don't think I help many people because of that, but it certainly helps me, if you know what I mean. When I am in the deepest points, and goodness knows we have had very deep points very recently, probably deeper for you, but I was not immune to what happened. It just crushed me. And but even in those moments, having a sense of meaning is very helpful. It's what to fall back to.
Mm-hmm. Yeah.
Sorry about this. I didn't want to.
I completely agree with you. We will not get into that subject because, I wrote a couple of essays on medium.com last week about it. So anyone interested in my views can find it there. But what I would say is on the expedition, on the boat, the ship, which was called the Silver Star, every morning at sunrise, I would jog on the deck. And one morning I was asked by someone, Avi, it looks like you're jogging, you're running. Are you running away from something or towards something? And I said both. I'm running away from some of my colleagues who have very strong opinions without seeking evidence. And I'm running towards higher intelligence in interstellar space. So that defines my journey. And, the reason I took it as of 6 years ago is because both my parents passed away around that time. And I realized that we live for a short time. And we better focus on substance, not on trying to get as many likes as possible on social media. I don't have any footprint on social media. And what I really care about is doing something meaningful that will promote the better good of humanity, prosperity for the future, advocating for the right things. And even if that attracts a lot of negativity, which it shouldn't. Why would it? If we are all staying curious, why is childlike bullying much more prevalent on social media than childlike curiosity? That is the fundamental question. Why is bullying more popular than curiosity? I don't know the answer, but I can say for sure it's also true in academia, not just in the public, and very true in academia. So I could have been saddened by that and perhaps halt all of my curious quests and say, why should I get into that? There is so much resistance and negativity. But instead, what I'm saying is, it's not about me. It's not about me feeling good about myself. It's not about me being liked. It's about advocating for the right thing. And, even if what I pursue, if it ends up that all these interstellar objects are rocks, so be it. At least, I try to check if any of them is artificial. There was a meaning to my life. I tried to figure out something that nobody else cared about. And so, to me, that is more satisfying than getting many likes.
You probably have heard this before. And if you do not have the same level of appreciation for the person I'm going to mention as I do, maybe you should just ignore what I'm about to say. But you remind me of John Mack, at the same institution, fighting a similar battle in a completely different way, from a completely different discipline, getting a lot of flack, but remaining kind, generous, and positive and optimistic. I don't know whether you see that.
No, there is one fundamental difference, that he was focused on humans. He was a psychologist, psychiatrist. So he was really focusing on humans. And I don't think of humans as scientific detectors because, if you have an accident and different people involved will give you very different reports. In fact, FIFA, agrees with me, because in the recent Women's World Cup, they used cameras to decide if there was a goal or not. They didn't go to the players. They didn't ask the audience what really happened. They used video cameras. And that's the way science is done, using instruments. I don't care what people say, because people have ulterior motives. They have hidden agendas. They can get easily misled. So John Mack was focusing on people. I say, no, I don't want to ask the players or the audience what they see. I want to use my video cameras. And that's a fundamental difference between me and FIFA. Not just me, it's also FIFA, right? And John Mack. John Mack would not necessarily get to the right answer when he would check if there is a goal, because he would go and ask around all the people. And I say, I don't care about the people. That's a big difference.
I understand the distance you're establishing between you and him. I think it's important that you say this too. I fully understand that. In his defense, he was a psychiatrist, so people were his raw data. That was his thing. That's what he studied. But I understand what you're saying completely. Yeah.
Right. The other thing is you have people sitting on the sidelines, in the audience, and they tell the soccer players how to pass the ball. So these are, bloggers, commentators, reporters. Some of them call themselves astrophysicists. At least two of them that call themselves astrophysicists did not write a scientific paper in the last decade and a half, a single scientific paper. And they call themselves publicly. They're very well known, highly regarded by the public, and they call themselves astrophysicists. And I ask, how can you call yourself something if you're not practicing it?
Yeah.
How can you preach without practicing? So my point is, I'm a practicing scientist. Just last night, I posted a scientific paper that I'm the first author on. Okay? And I do that routinely every month. I'm a practicing scientist, and I communicate to the public in addition to that. Those people who have a large voice and a large ego are not practicing, and they tell the soccer players how to pass the ball. And I say, who gave you that permission? Like, how can you tell me how to do my science when you are not doing science? How dare you do that? And that's another phenomena that has to do with social media, where a lot of people who have superficial knowledge express very strong opinions, and they get a lot of likes. And then the perception of so then reporters look at that and say, oh, I have to present the full picture. I have to
both sides.
what these people are saying. But what these people are saying is completely superficial, because they are not doing science. They are just expressing opinions. And therefore, the science reporter, is supposed to pay much more attention to the science, because otherwise, why would they call themselves science reporters? There was even a case where a science reporter reported something, and I said, here is a paper that shows that it's wrong. And they said, sorry, we wrote about it, but we don't want to confuse our readers now, so we will not make a correction. And another reporter said, well, after your paper gets accepted for publication, let us know. I let them know after it was accepted for publication, because it takes time for the refereeing procedure, and nothing happened. Why? Because they don't want to confuse the readers by showing a statement that is made by a scientist. However, they're happy to show controversies where people express opinions that are based just on their opinion.
I know exactly who you're talking about. I share your disdain for this, for those actions, that recurring attitude. I share the same disdain. Perhaps more. You were kind. You were gentle enough in expressing your disdain. You see this everywhere. The idea of the media that they have to portray both sides of the debate, even when it isn't a debate, even when the question is scientifically settled. You don't have to portray idiocy. That's not in the job description of scientific media, to portray idiocy. So I share that completely. When I'm in my more cynical mood, when you can't do science, you talk about it. And then you become the spokesperson for science, because it's easier. You're not doing the real work. Right? You're following the ebb and flow of the popular psyche. It's a psychology thing, Exactly. It's a mood thing. Exactly. It's not a hard evidence.
And you know what Arthur Schopenhauer said? He said that every truth goes through 3 stages. At first, it is ridiculed. Then it is argued against very vigorously. People say, no, it's wrong. And finally, the 3rd stage is, oh, of course, it's self-evident.
Yeah.
And I am adding a 4th stage, which is, we said it first. And you find that very often in scientific discourses. So I bet you that if unidentified anomalous phenomena end up being gadgets, technological things from other civilizations, I bet you that the SETI community at that point, after ridiculing the study and banning any discussion about it in their conferences, which is exactly what they're doing right now, they don't allow any discussion. The SETI community, who is searching for extraterrestrial intelligence, they just want the only search to be search for radio waves or search for laser signals, nothing else. So they are banning a discussion about physical objects near Earth. And if it happens to be the case that the US government, let's say, will come forward with a piece of equipment that they found somewhere, then the SETI community will say, of course, this is a subject that was discussed since the 60s or before that.
We knew it all along.
We were always talking about it. There is nothing really new.
Yeah. It's when you really take notice of the social dynamics involving science, media, and the public, it's scary what one comes across. I can give you an example from another domain, if we have time, Phidias, and a couple of minutes.
Yes, we have.
There were, we always thought that psychedelics had their effect by lighting up your brain like a Christmas tree. Turns out they do the opposite. We have known that for over 11 years now. They do precisely the opposite. And of course, everybody went to try to find something. If it's not brain activity that increases with psychedelics, something must increase in the brain. Reasonable enough. We should look for that. So started looking for functional connectivity between residual activity in different brain areas, looked at brain activity variability. So the first derivative, even if activity decreases, does the first derivative increase? So we looked at many things, functional coupling, and then there were papers published showing that some of these things do increase in the psychedelic state. For instance, resting state functional connectivity does increase. Activity decreases, but the remaining activity is more synchronized across different areas of the brain. So paper was published, and then you show 5 figures were showing reduced brain activity, so everything was green and blue in the diagrams of brain activity. And 1 figure was full of orange and red, showing increased in resting state functional connectivity. Guess what the media publishes? The media publishes that 1 out of 6 pictures, they remove the legend, they remove references to resting state functional connectivity, and then just show psychedelics light up the brain like a Christmas tree. And that was published by The Guardian, by CNN, by the Washington Post, I think. But it gets worse, because they credit the edited picture to the scientific institutions that did the research. So they didn't edit it. They were given edited pictures. And one of the co-authors of the paper goes to The Conversation, the academic blog, and basically says, yes, brain activity increases. You go to the paper and it's like, no, there's nothing here saying that brain activity increases. So you have this amazing play between psychology, ambition on the one hand, cultural expectations and unexamined assumptions on the other, the media doing what it does to get clicks, and the rest of the public watching and getting this incredibly distorted picture of the facts. Yeah. It is scary.
I had exactly this experience when I came back from the expedition, and many reports, even in distinguished magazines and journals, including the New York Times, they were basically twisting the message. And if you were to listen to podcasts or interviews that I had, you will get the message straight. Whereas if you were to read it in a newspaper article, the title would have nothing to do with the content of the article. In the content, it was distorted. And then you will have all these opinion makers that have nothing to do with science as it should be done. And so that is very disappointing. And now the question is, with AI getting better, there will be a lot of misinformation filling up social media. And we see that already during the wars now. And especially because it serves a political agenda or interests of some organizations. And the question is how to figure out the truth. How do you know what really happens? Because even videos and recordings could be manipulated. Yeah. And that's a serious trust issue that we will have with, and obviously the way information is portrayed shapes the way people behave. And so it could lead to completely inappropriate responses from communities of people. I mean, even if you're an idealist believing in important principles that are for the better of humanity, you might be fooled by information that is trying to say that these principles were violated, even though they were not in reality. Yeah. And so you will get into confrontations that are completely misguided. And it's really, I think, a very serious issue as to how to moderate that and what to do about that. Because on the one hand, you say free speech, but free speech, if you don't monitor whether it's reliable, could lead to chaos. And so the question is how to correct misinformation.
Yeah, I'm particularly worried about, we talked about ChatGPT earlier. I'm particularly worried about natural language interfaces to search, like ChatGPT, because when we are doing a traditional Google search, we know that Google is just giving us sources of information, but it's not passing judgment on whether those sources are correct or not. They're just saying, this source talks about the stuff you're looking for. And then we have the responsibility to evaluate, is this a reliable source or not? Is what they are saying something plausible or not? We take on that responsibility ourselves. But when you query a natural language interface like ChatGPT, you are not given sources. You're given an authoritative answer, like a professor laying down the ground for you and saying how things are. But ChatGPT, of course, is trained on what is out there on the internet. And even if you would calibrate the training algorithm to bias it towards reliable sources, even those reliable sources can publish absolutely nonsense, like what I just shared with you. It was published by The Guardian, by CNN, by The Washington Post, by The Conversation. I mean, these are reliable sources, better than the social media.
You have to go to primary, just like with food. You don't want processed food. It's not good for you.
Yeah.
So you don't want processed information. You have to go straight to the source. I think that would, in principle, could resolve it. And maybe, it's better to listen to a podcast by Phidias than read the newspapers. Maybe that's the solution, Phidias.
You're here.
Yes, definitely do that, guys. So I'm very curious. I don't know if you have something to add on the stuff. I'm very curious because this was an experiment that we did, like to have you guys both to chat. I'm very curious to hear live now your opinion about how was the experiment went. So we examined the experiment.
Oh, I thought it went fantastically well, much better than I expected. Yeah, I thank you for arranging it.
I think it went great. I expected it would go great. I think it depends on who you are pairing. Certain pairings will be like this, will go very well. Other pairings can descend into darkness.
Can kill each other.
Yeah. I think, but that's my own personality trait. I think a robust debate sometimes is very enjoyable and digs things out, brings everything to the light. But if it gets too emotional and contentious, like an experience I had recently, then nothing comes up that is of any use, and that can be a waste of time. So I think that the art is in pairing. And I don't mean by this only pairing people who agree with one another. I think the best pairings will be between people who disagree profoundly, are willing to debust robustly, but with respect.
Yeah,
like you guys did.
Yeah, I mean, we agree on many things, but the point is that what is missing these days are dialogues, because a lot of people just go to their own tribe and listen to opinions that represent their own. And I think it would be nice if you were to pair people that don't agree, but respectfully express their opinions. Maybe one of them will change the opinion of the other or not, but at least you hear both sides, and then the audience can decide for themselves. And that is the most valuable thing. I mean, it's just like the dialogues of Socrates, that he realized that speaking is an art form that allows you to see both sides of the issue. And what happens in academia, unfortunately, what happened in recent years was that people who said we are very open-minded, but we want to hear just opinions that are similar to our own. And that is a contradiction. You can't say that you are a liberal, but you can't hear or you can't tolerate someone with an opposite view.
Yeah.
And unfortunately, those people do not even realize that they're saying that. They say, we don't want those people to be on the campus just because we don't believe they have a good point to make. But that is not allowing someone with a different voice to express themselves. And what you can do in a podcast like this is bring people with different opinions that are respecting each other and respecting the dialogue, because that's the only way for us to get better. If we hear other people saying different things and eventually we decide what we want to adapt.
Yeah, I agree.
Okay, so you guys were my favorite guests in the podcast, so I'm very happy and glad that you guys matched together and we've had a beautiful conversation. I love you and thank you for being here. Thank you guys for watching.
Phidias, I should tell you that in Judaism, you can buy yourself a place in heaven if you matchmake 3 couples. Okay, so you have one. You still need to get 2 more.
2 to go, and you go to heaven, Phidias.
Good. I love you all, guys. Thank you for watching.
Thank you so much, Avi. Thank you so much. It was a pleasure.
Pleasure.